And moving forward here, just to make a comparison between the formatted input and output and unformatted. So, for instance, we have integer x, and it's assigned the value of 65. Now, if we take our cout device, right, character outputs, standard character output device, and send this x variable to cout, cout will recognize that this is an integer, and it's very likely to display the value of 65, decimal 65, which is the default radix or base for displaying integers. Now, if we take this integer x and instead say cout put, which is like display this character or display this this piece, it will understand that this is a single byte that needs to be sent out to the output, and it's very likely to display uppercase character A, because if we're using standard ASCII encoding of characters, then 65 corresponds to an encoding of a character A, and put would convert this integer to a single byte with the value 65, and very likely that if it comes out on the console output screen, is very likely to display character A. So you see that at this stage, cout doesn't really care whether this is a byte or integer. The whole idea of using the built-in member function named put is to display this as a single byte, process it as a single byte. So this is what this program should print, 65A. So that's the idea behind this type of those two types. So most of the time, this is what you want, okay? And unformatted output and input is reserved for more advanced tasks, like very likely things associated with just low-level storage, like programming your own database, for example. That's where you would want this unformatted way of doing the work. So I mentioned already that we include IO stream. This is the header to use. At this stage, let's just do a little bit of demonstration here. So again, we'll go to create our main function. And let's do a regular program right here. And so we'll use this example from that slide. We'll create an integer, I call it value, equals 1 to 65, right? 65 was the example. And of course, if we use std cout and display this value, and possibly also I'll just send out new line character to the output. And in addition to this, we can use this unformatted output, just like we did in that sample. And so we'll build this program. Okay. So this gets built, and when I run it, try running it on my system, this is the screen that opens with my debugging session, and you can see that this is what it's printing. It's printing 65A, separated by the new line. I'll rebuild this program one more time, and this is the name of my executable file that was produced. So if I go ahead and open my command line, I just open my command line, and I'll go to this location on just brought up like a command prompt to view, right? And once again, if I copy the path to this program, I can now go to my command prompt and run this program as a console program. But there are ways to redirect this output, this specific output can be redirected to a file. For example, I can type this redirection symbol, which looks like greater than sign, right? And I can redirect it into my file.text. See, this time if I use the redirection, the same program was run, but you no longer see this output. Instead, this redirection on the command line attached cout to a file named myfile.txt. And interestingly enough, if I open my file manager window and I go to this specific folder, right? So open this directory view right here. So this is my directory view. And if I just navigate to this specific place, you see that my file.txt was created. If I open it, here it is. Just open it, and it contains the information 65 and A, right, which is the result of the output right here that we were able to demonstrate. But this time, the output was actually redirected to a file. So a lot of this manipulation can be done on the command line with redirection and also connecting outputs from one program with inputs from another program. And so that's called piping. But simpler redirection to and from file are possible. Another version of redirection here would be to actually using a double redirection like this. This will be attaching information at the end of the file. So if I do it like this a few times and I reopen my file to take a look at it, you see that this information has been appended at the end of the file. So uh, this mode of redirection actually appends at the end of the file, which is something that you want to do with log devices. But if I go back to the original form of redirection, which is like the single greater than redirection symbol, and do it like this, and refresh the view of my file, you see that the previous information was destroyed, and it's being overridden again with fresh information from this program. All right, so this is amazing that all of this is possible by combining command line redirection with just such a simple idea as cout, which allows us to manipulate it and use it for the output of our values from the program. All right, so this is another segment that we've been able to demonstrate.